Hi students, how are you all? Welcome to the sixth part of electricity. Yeah, already 5 parts of these chapters are already made, and link of all those videos you will get in the description box. You must check that. And in this sixth part, mainly we'll discuss about, before saying you the topic, I want to ask you a question. A very simple question. Say, अब मान लो एक इलेक्ट्रिक बल्ब, हाँ, दैट इलेक्ट्रिक बल्ब से ये बल्ब 2 घंटा से जल रहा है. फाइन, ओके, मीन्स स्विच इज ऑन एंड द बल्ब इज फंक्शनिंग. मीन्स 2 घंटा हो गया, वो बल्ब जल रहा है. एंड आई एम सेइंग यू go and take out that bulb. Yes, now you are going and you are trying to open the bulb. Fine. Now if I ask you, क्या ये बल्ब गर्म है या ठंडा है? So you'll answer me, no, the bulb is hot. Yes, the bulb is hot. Not only that bulb, even your mobile charger, when you plug it in, when you plugged in your mobile charger, and after half an hour when you touch that charger, you feel that charger is hot. Means the temperature of that device has increased. Any electric device. So what I want to say you that whenever an amount of current passes through that device, it produces heat. Understood? Now, why this heat is producing? As we discussed in the portion, I think, third portion, we discussed about resistance. Yeah, third part of chapter electricity, we discussed about resistance. So, what is resistance? Resistance is something which opposes the flowing of electric current. Say, this is a wire. This is a simple electric wire. Now when, since this is a wire, so it has got some resistance, fine. Now when current passes through this wire, and since it has got a resistance, so it will oppose the flowing of electric current. Understood? But electricity will pass, though it has got a resistance. Say it's a copper wire, as I told you, say it's a copper wire, or any other conductor. When current will pass through this wire, since it has got some resistance, so that resistance will oppose the current, but current will pass. So current will do some work. Yes, that current has to do some work to pass through it because of the resistance of it. Understood? And due to that, some energy of that current will decrease. Understood? What I said? Some energy of that current will decrease. Now where that energy is going? That energy is converting into heat energy. Understood? So when an amount of current passes through a wire, since the wire has got a resistance, and the current has to pass, so that's why that current will do some work, and because of doing that work, some energy of that current will reduce, and that energy is converting into heat energy. That's why when an amount of current will pass through a conductor, or it's passing through a device, because of that resistance, and just to overcome that resistance, yes, to overcome that resistance, the current's energy reduces, and that energy converts into heat energy. That's why the electric conductor or any electronic devices gets heats up. It produces heat. Why? Because the current is passing through it. Understood? To overcome the resistance. Understood? That the amount of heat which is producing in that electric device or through this wire when current is passing, Now what are the terms on which the amount of heat production depends? How much heat will produce? That depends on actually three things. I'm not saying that this is actually the theory is explained by the scientist Joule. That's why we call it Joule's laws of heating effect. It's very important for your syllabus. Joule's laws of heating effect. In Joule's law of heating effect, we saw that heat production depends on three things. First is, what is the amount of current passing? Yes, if you send more current, understood? If more current is passing, then more heat will produce. Number two, resistance of that conductor or resistance of that device. If more resistance, then more heat. Number three, time. If you are passing electricity for more time, like say 10 minutes, instead of 10 minutes you are passing current for 20 minutes, you are increasing time, then the amount of heat will also increase. Understood? So when an amount of current will pass through a conductor, or when an amount of current will pass through an electronic device, that electronic device produce heat. From where this heat is producing? The electronic device or that electronic wire that contains some resistance, and to overcome that resistance, the energy of current reduces, and that energy converts into heat energy. Understood? And what we discussed, according to Joule's laws of heating effect, that heat energy, what is the amount of heat produced? That heat depends on three things. What are those three things? Amount of current, resistance, and time. Let me discuss it. Say this is the wire. Fine. Current is passing through this. Say I is the amount of current which is passing through this conductor, and R is the resistance of this conductor, and we are passing the current for time t, say for 1 hour or for 2 hour or for 3 hour. Say that's why we are considering that time is t. Now according to Joule's law of heating effect, Joule's laws of heating effect, the first law is amount of heat is directly proportional to the amount of current, not only amount of current, square of amount of current. Understood? So how much heat will produce, that is directly proportional to the square of current. Understood? Number B, amount of heat is directly proportional to the amount of resistance of that conductor. So heat is directly proportional to the resistance of that conductor. Understood? Number C, the amount of heat is also directly proportional to the time. Understood? So all this means if you increase current, heat will also increase. If you increase resistance, heat will also increase. If you increase the timing, duration, then more heat will produce. Understood? So by combining these three, we can write that H is proportional to I square RT. Fine? Or directly we can write H equal to I square RT. This is the main equation. You have to remember that. H equal to I square RT. What is I? Amount of current. What is the unit of it? Ampere. We know that. R is resistance. What is the unit? Ohm. Ohm is the unit. What is T? Time. But time has to be in second. So your time is in second. Understood? So by putting these values, if you calculate it, you will get amount of heat produced, and the unit of heat is Joule. Understood? Now, say a conductor is there. This is the conductor. Fine. Through which, say, 5 ampere of current is passing. So, what is the amount of current? 5 ampere. Fine. Resistance of the conductor is, say, 10 ohm. Resistance equal to 10 ohm. And you are passing current for 2 minutes. So, time is 2 minutes. Understood? Now, in this condition, if I ask you, what is the amount of heat will produce here? So, we can say that amount of heat from Joule's laws of heating effect, we discussed that H equal to I square RT. So, let us use that formula and put the values, get the result. H equal to I square RT equal to I is 5 square, R is 10 into time. Time is 2 minutes, but we have to use the time in second. So 2 minutes has to be converted into second. 2 minutes equal to 120 second. So just put 120. Now 5 square is 25 into 1200. Fine. Now 12 into 25. This one. Correct? So this Joule, J. Fine. So this is the unit of heat produced. So how much heat is produced? 30,000 Joule of, 30,000 Joule of heat is produced in this condition. I hope you understood what is Joule's laws of heating effect. But you have to also know the reason of production of heat. Why the heat is producing? Because current is passing through that conductor and that conductor has got a resistance. So to overcome that resistance, current is passing, and because of that some energy lost is there, and that energy lost is converted into heat energy. Understood? And this is the formula of heat energy production. Understood? I hope you understood this. So we'll meet in the next part of chapter electricity. Thank you.